one and the last one. So I'll have a quick look at variable transformation is the last one. So we'll discuss about variable transformation. What is going to be variable transformation? So variable transformation is going to what it is trying to do is, there are two ways in which variable transformation is going to be applied. Number one is going to be simple functional transformation, and number two is going to be normalization or standardization. Okay, so we are going to transform the variables. For example, we have variables which range from 1 to 1 crore. So on. So on, it is going to be a big number. So now this particular attribute is going to have a lot of influence on the results because it has a huge range. Therefore, this particular attribute is going to have a lot of influence on the result that we are going to get. So therefore, such huge range of attributes are not advisable. So therefore, these are going to be transformed. These are going to be transformed, and to see to it that their range is going to be smaller and they can fit into a very small range. Such things are going to be very, very useful. So therefore, we'll be discussing about two different transformations. Number one is simple functional transformations, and number two is normalization or standardization. So coming to the simple functional transformation, so a simple mathematical function is going to be applied to each value individually. For example, x is a variable. We are going to say x square, or log x, or e power x, or square root of x, or 1 by x, or sin x, or mod x. These are all going to be the way in which the transformation is going to be done. So that they fall into a small range. So that is what is going to be called as transformation. So they are very useful. So such transformations are very useful in intrusion detection of compute networks. For example, so let me say we have a compute network, and the data transfers range from 1 byte to 10 to the power of 10 bytes. 10 to the power of 10 bytes. This is going to be a very huge data. Okay. So now in such cases, huge range, in such cases, what I'm going to do is, I'm going to, for example, a given case, I have x bytes of transfer. Then what I'm going to do is, I'm going to calculate the log 10, log x to the base 10, log x to the base 10, log x to the base 10. If I'm going to calculate for this, now what I'm going to get is, I'm going to get a range from 1 to 10 only. I'm going to get a range only from 1 to 10. So that is where it is going to be very, very useful. So now this range is going to be better than such a huge range that I'm going to have. So now within this, if I am going to have, let me say, 8, the value is going to be something around 8, 9, 10. Then it is going to be a big data transfer, which can be considered as a file transfer. So file transfers, I can check for viruses that are being introduced and all these things. Small values between 1 and 2, there are going to be other transactions that are going to be done. So in this way, I'll be able to understand the nature of the data easily by using these simple functional transformations that are being done. And most important thing is, we have to be very careful. By using these functional transformations, because they might change the nature of the data. For example, example of 1 by x of values which are between 0 and 1. So if I apply 1 by x for a value 1 by 2, it becomes 2. Okay, if I apply 1 by x for a value 2, it becomes 1 by 2. So now this is going to reduce the range, reduce the value. This is going to increase the value. So such things are to be taken care. Such things are going to be taken care while we apply variable transformations that are going to be applied. And the last one that we are going to discuss here is normalization or standardization. So normalization or standardization is a very important technique that is used for variable transformation. So what is the most important intention is normalization or standardization is to make an entire set of values have a particular property. They are going to have a particular property. For example, let us look at standardizing a variable. For example, we say x bar is the mean or the average of a data set. Okay, and s is the standardization. Okay, so then then for each one of them, I'm going to calculate. I'm going, for example, x is the variable. X is the variable. Okay, for the x variable, what I'm going to do is I'm going to standardize each one of them. I'm going to do a calculation x bar is equal to x minus. Many times you must have done this in statistics. X minus x bar by s. So this is what is going to be the value for each x bar. Each value is going to be x minus mean by the standardization. So what is going to happen here is the mean is going to be fixed. Okay, the mean value is going to be fixed. The standardization value is going to be fixed by doing this activity. So this is what is the intention is the entire set of values are going to have a particular property, fixed mean and standardization. So that is what is the intention. That is what is the intention of normalization or standardization. So these are the different pre-processing steps that we are going to make. So that the different pre-processing steps that we have discussed today are feature selection. Then we have discussed about feature creation. Then we have discussed about discretization and binarization. And finally, we have discussed about variable transformation. So with this, I end my lecture for today.